This question states a bullet of mass capital M is fired with a velocity of 50 meters per second at an angle of theta with the horizontal. At the highest point on its trajectory, it collides head-on with a bob of mass 3m suspended by a massless string of length 10 by 3 meter and gets embedded in the bob. After collision, the string moves through an angle of 120 degree. Find first the angle of theta, second the vertical and horizontal coordinates of the initial position of the bob with respect to the point of firing of the bullet. Take g as 10 meter per second square. So in this case, first of all, we are going to draw the diagram. So we have a bullet. This is x coordinate, y coordinate, and we have a bullet which is fired at an angle of theta with the initial velocity of u at angle of theta. At the highest point, let this be highest point be P, a bob is suspended from a point C with the length of the string which is given by 10 by 3 meters. So as the bullet hits the bob, it moves by angle of 120 degree. So let us suppose the position is Q. So this total angle is 120. We can say that this angle will be of 30 degree if we draw a perpendicular line with respect to point PC. And let us suppose the total height between point P, between the final position of the bob, that is Q, and the initial point of the bob P is given by h, and the distance of point Q above point C can be written as, let us call this as L. Let's call this length PC as L, so we can write this as L sine of 30, or we can say that H will be equal to L plus L sine of 30. Let this call this a point as origin O. So at O, the horizontal component u of x will be equal to u cos of theta, and u of y will be equal to u sin of theta, and at the highest point P, horizontal component remains same, so we can say that v of x will be equal to u of x, which is equal to u cos of theta, and v of x, and v of y, that is vertical component, will be equal to 0. So first, applying linear momentum conservation, or we can say applying conservation of momentum, applying conservation of linear momentum rather, conservation of linear momentum. You can say that mux will be equal to m plus 3m multiplied by v, where v is the final velocity, and the final velocity we already know. So we can say that v will be equal to let's solve it. We get m ux is equal to 4m multiplied by v. So from here we can find out v will be equal to ux divided by 4. Next we are going to apply conservation of energy of the bob. Conservation of energy. So we are going to get half m plus 3m v square will be equal to m plus 3m gh. So this will be equal to half multiplied by 4m u square is equal to 4m gh. So m goes with m, 4 cancels out by 4. So we can say that v square is equal to 2gh, and value of h we already know is given by L plus L sine 30. So write that v square is equal to 2g L plus L sine 30. And v we already know is given by ux by 4. So v is equal to ux by 4, and ux is u cos of theta divided by 4, and initial velocity is given as 50. So we can write 50 cos of theta divided by 4 is barabar v. So we are going to substitute this value of v here, and we are going to get it as 50 cos of theta divided by 4 whole square to value of g is 10, and we can write this as 1 plus sine 30, taking L is common, and L is given by 10 by 3. This can be written as cos square theta is equal to 4 multiplied by 4 divided by 50 multiplied by 50, 2 multiplied by 10 into 10 divided by 3, and sine 30 is 1 by 2. This will be equal to 4 into 4, 50 into 50, 2 into 10 into 10 divided by 3 multiplied by 3 by 2. 3 goes with 3, 2 cancel out 2, 10, 10, 10, 10, and we are left with only 16 by 25. So we can say that cos of theta is equal to 4 by 5. This implies that theta will be equal to 37. This is our first part. In this B part, like the second part, we are going to find out what will be the coordinates. So we can draw a we know that this is point P. So this, let us assume, is x distance from the origin, and it is a height of y. So coordinate will be x comma y. And if t is the total time of flight, then we can say that, let us call this as O, P and B. So we can say that time OP is the time of flight, which is given as 2u sine of theta upon g, where u is initial velocity and theta is angle of projection, and time of flight of OP will be equal to half of TOB. So we can write this as u sine theta by g. We are going to use, in order to find the horizontal coordinate, we can say that the distance x will be equal to initial velocity in x direction multiplied by time t. Initial velocity in x direction is given as u cos of theta, and this t is given as TOP. U we already know is our 50, theta we know is 37 degree, and TOP is u sine theta g. So we can solve this. We get 50 cos 37 into u is 50 sine 37 sine 37 sine 37 divided by 10. So we get x as 120 meter. For the vertical component, you can say that Sy is equal to u by t plus half ay t square. You can say that this t will be coming as 3 seconds. So indirectly we can substitute this value as 3 also. So x will be the same. So S of y is given as y. So y is equal to is 50 sine 37 into 3 minus half g is 10 and 3 square. Solving this, we are going to get y is equal to 45 meters. So the coordinate of the initial coordinate of Bob is given as 120 and 55. Thank you.